What we do is we write dose calculation software for radiation treatment planning. And to try to explain that, I'm going to show you a quick video. So I'm going to share my screen here. And okay, so when people have cancer, one of the ways we can treat it is by using radiation. And this man you see here in this video is being treated for a brain tumor using a machine called a linear accelerator. So this is one of the most common methods for treating cancer with radiation. It's not the only method, but most of the time this is the one you hear about. On the man, that's called
video is super laggy because there's
and
a
that
video
delivers radiation. You can't see it because radiation is invisible, but it's delivering radiation dose to this man's brain, and it's going to help stop the cancer cells. So I'm gonna stop the share here. Okay, so the great thing about radiation is that it stops the growth of cancer cells, it kills existing cancer cells, and healthy cells. So we have to be really careful with it. And what we try to do with radiation is send a maximal dose of the radiation to the tumor, but we want to be very careful not to send too much radiation to the surrounding, structures, organs, maybe it's a lung, a brain, whatever. So that's our goal. And because it's so important that we kill the cancer without hurting the healthy tissue, there's a lot of checks and balances that are involved when you treat a patient with radiation. So my software is one of these checks and balances, but there's also measuring devices that measure the projected dose before the patient's treated. There's treatment planning systems that are crazy sophisticated that make sure the patient's getting the right dose. So all of these systems have to be in agreement that says, yeah, the patient's pretty much getting the dose we calculate. Before he can even be treated at all. We take it really seriously. So, how do we use computational thinking? Well, calculating the radiation dose to a patient does sound pretty complicated. And, it is. So one of the ways we make it easier is we break it down into steps that are much simpler. So it's called decomposition, but when calculating a dose, we have to think about certain things. Well, what kind of radiation is it? Because different types of radiation behave in different ways. And what do we need to do? Are we calculating deep within the patient? Are we calculating near a bone? How big is the field? And once we know each piece of data here, we can better understand how to structure our algorithm, which I'll talk about later. Basically, we'll better know how to calculate the dose. So the other thing we have to do is, this is a process called abstraction. So we have to focus on what's important and try to make sure we ignore the stuff that isn't important. There's a lot of data here when you're talking about treating a patient with radiation. So for what I do, I calculate the dose to a patient. What do I need to know? Well, I need to know what type of radiation, what treatment modality. Is he being treated with a linear accelerator? Is he being treated with, like, for example, a live radioactive source that goes inside the patient? Where is this patient being treated? Are we talking about a lung tumor that's going through a lot of air? Are we talking about, maybe a esophageal or a brain where there's not maybe so much air? So that's another thing. How big is the area being treated? That's pretty important for a dose calculation. Where's the point? Like, we calculate dose specifically to one point in the patient. So we need to know that. What don't we need to know? Well, I don't care how a linear accelerator works. I don't need to know that, so we can ignore that. I don't need to know the patient's medical history. That's pretty important to the patient. It's not important when calculating a dose. So that's another thing we ignore. I don't need to know anything about the medical team, the hospital this patient's at. So we have to identify just what parameters our software needs to work. So that leads us to another thing. There's all kinds of possible radiation treatments. Like I mentioned, there's one called brachytherapy. It's where you have an isotope, a radioactive isotope that actually goes inside the patient. There's the linear accelerator and the video a tiny little linear accelerator on a robot arm. So, and there's also one called Gamma Knife, where the patient's head actually goes into a machine containing live sources. It's pretty interesting. The calculations are slightly different for each type of radiation, but some aspects of it are the same. We still need to know how the radiation behaves. We still need to know, and by behaves I mean how the radiation interacts with the type of tissue. Like brain tissue is different from lung, which is mostly air, which is different from bone. So no matter what type of radiation, we need to know that. We still need to know the size of the field. We still need to know the point. So basically, this is us looking at patterns. This is pattern recognition. So that helps us group together some things that are the same, and then, and then once we know all this information, the last thing we do before writing our software is we have to put together an algorithm. We have to go through step by step, like a recipe, like if you were baking cookies. You follow step by step, what do you need to do? So here we think, okay, we know the type of radiation. So this is the calculation type that we need. Okay, we know the calculation type. What are the parameters that go in this calculation? Well, we need to know parameter A, field size, say. Well, how do we get that? Okay, here's how you calculate field size. So I basically break this down into manageable parts, and before you know it, you have a pretty complex dose calculation, but it doesn't feel complex because we were able to use computational thinking to help us get there. So basically, calculating radiation dose is pretty complicated, but so are a lot of things. The trick is they'll be able to solve the most complex
This video is lagging way too much to me.
Yeah. Thanks a lot.
Half the video was just like, and it's kind of weird. It was weird.
Why is it so silent?
Sorry, I was on mute. Okay, so I was saying, I understand there are some lags in between, but you were able to listen to what she said, didn't you?
Some parts I couldn't understand, but most of it, yes.
Okay, so oncology is a field of it's a radiology, right? It's a field of radiology where they're treating, they're coming up with these machines to treat cancer, and it's extremely complex. So what she's saying is, they were able to take the complex problem of this cancer treating machines, right? Building cancer treating machines. So they were able to come up with small tasks that they can design, and they were able to use pattern recognition, decomposition, and finally algorithmic thinking to bring everything together to solve the problem, right? So I can also share this link with you. So if you have any more questions, Tammy also can help you. Help you understand the concept better. All right. So what is decomposition? Does everyone know what is decomposition by now?
Yeah.
Yes.
Okay. Can anyone tell me?
So when you
It
break
is-
down a problem,
It's breaking down like problems into like smaller steps.
It's breaking down a problem into multiple steps. Yes. And why do you do that? Why do you break it down into multiple smaller steps? Why
So
is
it's
it important to
easier
do that?
to do it like one step at a time.
Right. It's easy to, it's basically what we're trying to do is it manageable, right? So if the problem is too complex, it's not manageable. You cannot handle it. So what we're doing is we're trying to bring it to a manageable chunk, manageable problem set. So you can easily solve it, and then you can put it together. That is decomposition, all right? So it's a process of decomposing a complex problem into smaller problem sets. Now, what is pattern recognition? Anyone?
Is when you see like a pattern between, like if there's like a problem or something, or there's like past problems like this, and you see the pattern between them, which you could use to help you solve the main problem.
Right. So if you have a large data set, you try to identify patterns, because when it is too large, it's hard. It's hard to know where to start, where to start. So you try to identify what all the patterns that you can have. And yeah, so you can try to identify what all the patterns you can have, and try to solve the pattern. So try to come up with a general pattern, and you solve the pattern. If you solve the pattern, then you can solve the entire problem sets. Okay, so that's pretty much it. And last time we talked about this example, right? Example of starting at 8 a.m. in India and reaching US at 4 o'clock in the next day, right? So there were several steps. Did anyone miss last time what we did here?
I wasn't here.
You weren't here last time? Okay. So, okay, let me go through this real quick. So I was giving an example where I started in India at 8 o'clock on Thursday. And I took a boat at 9 o'clock. And after that, I reached the train station, and I took the train at 1 o'clock. And from train station, I reached the airport and took the flight at 6 o'clock. And on Thursday, I started at 6 o'clock, and the next day at 3 o'clock, I reached US. And again, I reached home at 4 o'clock on that day. So there are several steps involved here, right? So it's a big journey that I had to take, and there are multiple steps. So I was explaining you the abstraction. I was asking you some questions on what do you identify as a variable, right? So what kind of variables that you identify? So what were the variables? Anyone who attended last time? What are the variables that you found when I have to ask you the time, the duration it took from one point to other point? What are the variables that you need?
Start and end time.
Start time and end time, that's right. So you got start time and end time. And when you have start time and end time, what were you able to calculate? The duration.
Travel time?
The travel time, right. So I was explaining abstraction when I was doing that. So we can use the same example, and we can see how you can apply decomposition, for example. And you can also apply pattern recognition. So from this problem sets, can you all think of any patterns that are at play here? What is the pattern that is going on here as we start the journey from one end to the other end? What is the pattern that you see? What is a common pattern?
I have no idea.
Anyone else?
No.
Increasing by hours, I guess. I don't know. Kind of confused.
So the pattern. So okay. So what is the common pattern here? There is a pattern where we are starting at some point and ending at some point. Correct? Here we are starting here and ending here. Again, we are starting here, ending here, starting here, ending here, starting here, ending here, starting here, ending here. Right? So start and end, start and end, start and end. So there are multiple patterns going on, correct? So you could think of that as one pattern that is going on in the problem set. Okay? And what is the other pattern that you can think of? What is the, I mean, when I say pattern, what is the common between these pictures? What is the common thing that you're seeing in these pictures?
They're all vehicles.
They're all vehicles. That's good. So you have to take something to reach your destination, right? You need to have some vehicle. It could be a board, it could be a train, or it could be. So that could be a pattern too. So you're using something. right? That is a repeating that is something that is repeating rather. Okay, so that is your pattern. That could be your pattern too, right? So again, when something is repeating, you can take that out as a variable also, correct? When something is repeating, then you can actually, when you're trying abstraction, you can abstract it out and see and derive that as a variable. Okay. Any more questions on this slide?
No.
Okay. So let's jump into the problem sets. Okay, so how do we do this? Again, has anyone else had issues getting into Dynos? It sounds like a lot of people already logged in and you're trying your own thing here, right? Yeah, if you have any issues, I think Sanvi joined this week. If anyone is having issues, let me know. I can actually get with you after the class, okay? So let's take that example that I was talking to you. Okay, so let's start out with decomposition. Okay, so we were talking about starting point, ending point, right? So starting point in India is 8 o'clock. Boarding time at the board is 12. The next boarding point is at the train station. It's 14. I said it's 14 because it could be like 2 o'clock, right? And 16. So travel time. So now if I ask you a question, what is the travel time between airport and the train station? What would that be? What is the travel time between airport and train station? How?
2 hours.
2 hours? Okay. And what is the travel time between the airport and the starting point?
8 hours.
8 hours, right? So can you use decomposition and try to break this down into multiple pieces?
Yes.
Okay, how do you do that? Explain to me.
You could first figure out how much time it took you from India to the boarding time, and then how much time it took you from
At the boat.
to the boat, and then how much time it took from the boat to the train station, and then how much time it took from the train station to the airport.
Excellent. That is decomposition, exactly. So let's see how we can do this using Dynos. So now this is 8, 12, 14, 16, right? So can we use variables here instead of static numbers? Yes?
Yeah.
Okay, so let's use a number. And I'm going to change this to 8 here. And the boarding time at board is what? It's 12 o'clock. So let's change this guy to another variable. Input number. And the number here is 12. And instead of 14, let's use another variable here. Let's use a number. And it was 14 here, right? And here, instead of 16, I'll say another number. It's 16 here, right? So now, so the travel time between airport and the train station, you said is 2. So how did you get that? What would be the formula here for the function?
16 minus 14, number 4 minus number 3.
Excellent. So it would be number 4 minus number 3, right? So now if you change these numbers, for example, if this is 16, if I change this to 20, it would be 6, right? So now we asked a question. So what is the travel time between the airport and the starting point? correct? So how do we do this? Using decomposition. So the first step would be what? The first step would be
Finding the time, finding the airport time and the starting point time.
okay, so boarding time, basically this is the travel time to reach airport from, well, let's start from the starting point. To reach board station from starting point, right? And the second step is travel time to reach train station from board station, and travel time to reach airport from train station, right? If we add 3, add 1 plus 2 plus 3 to get the total travel time, right? You see that? So that is decomposition, correct? So now let's, for step 1, what would be the formula here to reach board station from starting point? It would be number 2 minus number 1, correct?
Yeah.
Yes.
And what would be the travel time to reach train station from board station? What would be the formula? So now I'm selecting a function. So what would be the function here?
Number 3 minus number 4.
Number 3, wait a minute. Number 3 minus what?
Number 2.
Number 2, that's right. Okay. And now finally, for number 3, what is it? What is the function for travel time to reach airport from the train station? Number
4 minus number 3.
Number 3. Yep. So you have 3 functions here, right? Function 1, function 2, function 3. So we just need to add these 3, correct?
Yes.
So what would be that function? It would be function 1 plus function 2 plus function 3, correct?
Yes.
Okay, so let's change this. There is a problem, I know that, we're fixing that, but let's try this one. So this would be the formula, okay? Function 1 plus function 2 plus function 3. Okay, so if you do that, then that would be the final answer. That's how you arrive at the final answer, okay? So now, any questions on this?
No.
Can you all solve the quadratic equation? Do you know what a quadratic equation means? So we have 8th graders here, 7th graders here. Do you have 10th graders, 9th graders? Okay, so quadratic equation is if you have if you have an equation where you have ax squared plus bx plus c equals to 0, you will be able to solve for x if you know the values of a, b, and c. Does this look familiar to you? Man, okay. So, yes? Okay, so the value of x would be, okay, maybe, okay, it looks like you haven't learned this yet in your school. So the value of x would be, x is minus b plus or minus square root of b squared minus 4ac divided by 2a. I may have screwed this up if 2a is for the whole thing. Let's see. So this is a big equation, right? Yes?
You can't really see it.
Down below, can you see it?
Yes, yes, we can. Can you just go like a bit more? Yeah, now I can see it.
Yeah, we're good.
Okay, so can you see this equation?
Yes.
So this is how you would solve for x when you have quadratic equation, right? Do we have any 7th graders here?
Yes.
Maithili,
Yeah.
did you learn about quadratic equation in 7th grade or no?
No.
No, not yet. Okay.
Algebra 1.
Algebra 1. Okay, so do you all know any other equations if you don't know quadratic equation? Do you know, trying to think, calculate radius? Okay, so let's see. Do you know how to calculate the triangle? You get okay, if you have a triangle, if the triangle has two sides, A, B, if it is a right angle triangle, do you know how to calculate the hypotenuse?
Yeah.
What's the formula for hypotenuse?
A squared plus B squared equals C squared.
Right, what do you see there?
The hypotenuse.
Who's talking here?
Above.
Satvik? Above, okay. So above, so you got, that is pretty simple, right? So let's see, I'm trying to see if we can use decomposition here. Can you think of using decomposition there?
Okay.
How do you come up with C square when you have A and B?
Well, square the numbers first. But if they're already squared, then like
It's
you
pretty
just
simple
add.
problem. Yeah, if you have multiple problem sets, then I think you can solve it. So let me this if the people on call, if you all don't know what quadratic equation is, I can think of another equation and I can give it to you as a homework. Is that okay? So basically what we are trying to do is, if you have I can make up something. I mean, we already have a function there, right? So what we're trying to do is, you can solve any math equation here. It doesn't have to be a quadratic equation. Okay? So let's say if you want to solve any math equation here, let's say you have another equation. Let's try ax plus bx plus c equals to 0, right? Ax plus b. So do you all know algebra? Have you seen this before, algebra?
Yeah.
Okay. So
Yeah.
if I give you the values of A, B, and C, okay, let's actually try it in a different way. Let's say you have all the values. You know the value of. Let's make this a little bit more complicated. Let's say squared. So let's say you got ax plus bx plus c squared equal to 0. Okay. So now let's say you know the value of A, you know the value of B, you know the value of C, and I also give you a value of X, right? So how do you calculate this equation? Not even 0 actually. So let's say some D, okay? So now I give you the values of A, B, C, and X, okay? And I say, what is D? Okay, what is the value of D? Okay? Are you guys with me?
Yes.
So how do you
Yeah.
calculate D? Can you use decomposition to calculate D? Yes?
Yeah.
How do you, can you give it a shot? Suhas? So as a step one, let's say if we have to do multiple steps. So step one, can you calculate what is AX is? Right?
Yeah.
And step 2, we can calculate what bx is, right? B
Yes.
times x, right? And step 2 is b times x, correct?
Yes.
And step 3 is what?
C squared.
C squared, right? And once you know step 1, step 2, step 3, you just have to do as a step 4, what do you do?
Addition. I'll add them all together.
Add all of them together, right? That is decomposition. You follow me?
Yes.
Okay. So once you have that, that is it. So that is decomposition. So you're breaking down the problem into multiple problem sets, and you're adding them together. So you can have we're taking the example of math. You can also take another example in science also. Can you all think of any example in science where you decompose it and solve a science problem?
Whenever you
When you're
have
combining elements,
an equation or an experiment,
Okay, Pari. Okay? So you're saying combining elements. What elements are we talking about?
I didn't say elements. I said an
like
experiment.
periodic
You said an
table
experiment.
elements.
Okay. So okay, I hear for periodic table elements. You know what? Hold on the periodic table elements we talk about in pattern recognition. Okay. So Pari, what are you talking about on the excuse me, on the decomposition?
I said experiment.
Experiment. Okay. So you can break down the experiment in multiple steps.
First, we would need to find out what you're going to do your experiment on.
Mm-hmm.
Second, you will need to find out, like, what's the problem and what I think is going to happen to it
Mm-hmm.
after I do this experiment. And thirdly, you have to, like, find out the steps to actually do the experiment.
Okay.
And then after that, fourth, you have to, like, see what you did and see what difference it made and see if you were right or wrong.
Okay.
And fifth, what some people do it, some people don't. See, like, what happens if I did it in a different way. Like, what if I was making pepper? What if instead of adding, I don't know, red chili pepper, maybe I'll add green chili peppers?
Okay. So so basically on the overall, what you're saying is you take a lab experiment, so you try to use decomposition and try to break the whole experiment into multiple steps, right? And try to do the experiment properly, right? So there are multiple steps that you need to do, basically preparations, right? So you have to do a lot of preparation work in order to do the experiment. So you will do for all the prep work, you do that separately and you bring everything together to solve the problem, right? That is decomposition. That's an excellent example. Yeah. All right. So I'm going to give an assignment on this one, so you can all try different things using decomposition. Okay. Now let me give you another example on pattern recognition. So let's jump into English on the pattern recognition. Okay, so I have some example sentences here. We can have more sentences here. Let's see, taking Lasya example. Lasya reads a book. Okay. So in the 3 sentences, what is the pattern you're looking at? What
They
is the
do
pattern you're
different
recognizing?
things.
Okay, patterns observed. Okay, so what is it? They do different things. Think in terms of English grammar.
They all have like a direct verb.
They all have a direct verb, okay? Who else? What is the pattern you're seeing in all three? When I say pattern, what is a common thing that you're seeing? Sanvi, are you able to follow what action? There is an action in all three. You have action, right?
There's an action, there's a noun.
All three have action, okay?
There's a person in all of them.
There is a person in all of them, okay?
There's a noun.
There is a noun, okay? So you have a direct verb, okay? Is there an order of things? What is the order we have? Do you have a subject in there? Do you know what a subject means?
Yes.
Yes.
Okay. So do you have a subject of all three starts with a subject?
Yeah.
I'm not explaining what a subject is because does anyone don't know what subject means? Subject, verb, object?
Oh,
Yeah, I know what a subject is.
Okay. So all start with a subject. We agree?
Yeah.
Yes.
all have at least 4 words.
Okay. I don't know. Okay, all have 4 words. And
All of them at the end of all the verbs is an S.
all have a verb, all have a direct verb, all have an object also, right? All start with an with a object, and all
All start with a noun.
start with a noun, a subject. You can say subject, right? Subject or a noun. What is a noun? I gave this to you. A noun is a name of a person, place, thing, or an idea, right? It's a noun. Noun is pretty generic. All end with an object, okay? Right? So now, if you were to generalize this, you got all these 7 things, right? So you can have probably more things. So can you think of a general pattern? For example, if we were to come up with like this plus this, so you can replace this with anything. What would this be? Pattern. So if I were to come up with a pattern like this, so dash plus dash plus dash. This could be, do you all agree this could be a subject here?
It could.
And this could be a direct verb, right? Right? And plus, this could be an object, right? This is called simple sentence, right? You have simple sentence and complex sentences, all of that. So this is a pattern for simple sentence, right? So this would be a subject, and this would be a verb. The third one would be an object. So let's replace this a variable, right? So we're also using a concept of abstraction here. So we're finding a pattern. We're also using abstraction. We're abstracting out and saying, we're calling this, the first one is a subject. Okay, so for subject, this could be,
Dropdown.
actually, let's use a drop-down. How about we use a drop-down here? So we can have a list of subjects here, okay? So here there is another, this is a verb, right? So let's replace this with a set of verbs. This could be another drop-down list. And this is another, the variable 3 is basically, it's an object, right? And now we can replace with another drop-down. So now we have drop-down 1, drop-down 2, drop-down 3. So we have 3 variables here, right? So now I lost my mouse. I have to use. So now, gonna give me 1 second. Let me just. All right. So drop down 1. So can you give me the list of choices for drop down 1? What would be the subjects here? Could it be Jim, Akhil,
Yes.
Lalasya?
Can be anyone.
We can have any more, right? We can have Sanvi. Anything, right? So this could be nouns, right? Nouns are subjects. Okay, we can have any more choices here. Now for drop down 2, what would be drop down 2? So this is a verb.
So jumps, rides, and reads.
Jumps, rides, and reads, right? Anything else? So eats. Okay. So now for drop down 3, we have object here.
Table, bicycle.
We can have, we can say actually a table or just table. A bicycle. A book, right? You see that? Now, so you can replace the gym with something else, and you can do mix and match with this pattern, right? You can have multiple sentences with the same pattern. You see that? So now Jim jumps a table, jumps on a table, uncle. So you can say rides. You can replace with anything, right? So technically, this is a sentence, right? This is a simple sentence. It may not make sense, but grammatically, it's a correct sentence, correct?
Yes.
Jim eats a book. Jim writes a book. It doesn't make sense, but it's a sentence. It's a simple sentence. You got it? So that is a pattern. So that is called pattern recognition. Do you all have any more examples that you want to try? Do you want to do a science example? Somebody's talking about periodic table. Who likes to draw on my board here? Annotate, clear. Okay, so clear all my drawings. Okay, so do you want to do periodic table? So who doesn't know periodic table? Does everyone know what a periodic table is?
Yeah.
Okay, so let's do this. Does anyone know what metals, non-metals are?
Yeah.
Yes.
So
Yes.
some of the
Yes.
elements that you know. Do you know what? Gold, okay.
Titanium.
Titanium.
Silver, oxygen, hydrogen, helium.
Hold on. So elements.
Uranium.
Lithium. Are we doing just?
Hold on. So let's do some easy one. Do you like sodium?
Yes.
Sulfur.
Sulfur?
Potassium.
Hydrogen.
Hydrogen.
Helium.
Helium?
Oxygen is not an element. Molecule.
Lithium.
You're testing my chemistry now. So let's see. Sodium. How about aluminum?
Oh,
Yeah, sure.
Aluminum. How about iron? Iron is a metal, right? How about you said oxygen, right?
Oxygen isn't an element, though.
A molecule.
Oxygen is not an element. You sure on that? Does oxygen belong to a periodic table or no? It can be an element.
I don't think it's
Well,
an
it's not.
element.
It's not in the periodic table.
Who said that?
Above.
Okay, so let's pick a beautiful periodic table here.
Okay.
Let's take forever. Okay. You see this above number 8?
Oh yeah, I
Oxygen.
see it.
Okay, hydrogen. So everything is in periodic table, guys. If something is not in the periodic table, means we'll be in trouble.
Water isn't.
Yeah, everything I mean, we're not in trouble, but which means we don't. I mean, we have some. We don't know something about few things. For example, what's the metal in Black Panther movie? Ultimatum? What is it called? I forgot. Have you all seen Black Panther?
Yeah.
Yes.
Vibranium.
Huh?
Vibranium.
Vibranium won't be in periodic table, guys.
Yeah, it's fake.
Okay, so yeah. All right, so elements: sodium, sulfur, hydrogen, aluminum, iron, oxygen. How about chlorine?
Potassium too.
Potassium. Okay, so all these elements, right? So how do we go about recognizing patterns? How about some questions? Let's ask some questions. Question 1 is, does this element have a positive charge?
Or negative.
So question 2 is, how about, okay, does it conduct electricity? Does this element conduct electricity?
How about, do we see this element every day?
Huh?
How about, do we see these elements daily?
How about we use these elements daily? Is that what you asked?
Yeah, do we use them daily?
You don't use them, well, I mean, oxygen you use daily.
Some of these daily. Sodium, I'm pretty sure too.
I mean, you have these elements.
Sodium is salt.
Yeah. So you use these
Chlorine is
for
salt.
everything. Yeah. Sodium chloride, for example. It's yeah. You have these elements in your room right now as we speak. Some of these. Does this element conduct heat? Right. So okay. So for question 1, now when we have that, so you're trying to come up with a pattern, right? So what's your answer for question 1? So for sodium, does it have, I'm going to say Q1, Q2, Q3 here. So sodium, do you know if it has positive or negative charge? Or neutral charge?
I think
Anybody?
it's positive.
I'm just writing Q1 here. Sodium has positive charge, right? What about sulfur? Sulfur has positive charge or negative charge?
Positive.
Are you
I'm
positive?
pretty sure.
What about hydrogen? Hydrogen has positive, right? Aluminum.
Yeah.
Positive and negative. No, it has both. All of them have both, except for hydrogen.
I don't know about hydrogen, but I'm pretty positive that aluminum has positive. It doesn't have negative. Iron.
Yeah.
Positive.
Okay. Oxygen?
Positive.
Yeah.
No, oxygen, no. Chlorine.
Negative.
Chlorine is negative. Yes. Chlorine is negative. Potassium.
Yeah.
Potassium is?
Positive.
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 Okay. So if you have positive, that means it is a metal. If it is a negative charge, it's a non-metal. Okay.
Hydrogen is metal though.
Huh?
Hydrogen is a metal.
Hydrogen
Sodium
has
and
positive
sulfur
charge?
aren't.
Yeah.
Okay, you need to look it up. I mean, I'm not sure on this hydrogen part. Hydrogen could be positive or negative, I guess. Well, hydrogen is it has a different one, right? So all these are all metals, lithium, sodium. Yeah, I don't know about hydrogen. Hydrogen, H2O, H is positive, right? So hydrogen can be positive or negative, I guess, right? I'm not sure. So you can tell me. So what about
I
oxygen?
think it's neutral.
Hydrogen is neutral. Okay,
Yeah.
we don't know. I'm not making any. Hydrogen could be positive. I know helium is negative. Helium is neutral. Okay, oxygen negative. So what about conductor of electricity? Conductor of heat. All metals,
No.
they are conductor of electricity and heat. Okay.
Yeah. So aluminum and iron are.
Aluminum and iron are. Okay. So now, if you were to come up with metals and non-metals here, metals, non-metals, right? So you can actually come up with a variable. Let's write a list, right? It could be you can do a drop down again, and this time you can call this metal, right? The title is metal, and this could be anything. So you can write some properties on the metals down below, and list out all the metals that meet the criteria for metals here, choices, right? For example, sodium is a metal, sulfur. I'm leaving out hydrogen. I'm not sure on the hydrogen part. Aluminum, iron. These are all metals, right? So you can list out all the properties of metals here. For example, has positive charge, conducts electricity, conducts heat, right? So wherever you have metals, you can simply say hashtag dropdown 4. Sodium has positive charge. Sodium conducts electricity. Space. Sodium conducts heat, right? If you know more properties, you can do that. So these are all metals, right? So you can replace sodium with aluminum. It has the same properties, right? So this is pattern. And you can do the same thing for non-metals also. Okay, non-metals, give me an example of non-metal. I mean, basically, it's quite opposite. I don't have to do this, but it's quite opposite. It has negative charge. It's not a conductor of electricity. It does not conduct heat. Okay? Oxygen, chlorine, potassium, not potassium, oxygen, chlorine, any other non-metals that you know of? In the periodic table, if you go to periodic table, you can see all the non-metals and metal. These are all metals, sodium, potassium, RB is rubium, I think, right?
Scandium.
Yeah. Magnesium, calcium. Did you say cadmium?
Scandium.
Scandium. Is it a metal?
Uncle, time is up.
Okay. So yeah, it's 4:05. So yeah, so you understand the gist of this, right? So this is pattern recognition. So if you have any more questions, you can hang out. You can I can answer them. If you have any questions on the on anything that you did last week, if you need a class code or something, I'm here to help you out. And other than that, I'm going to give you a couple of more assignments on the decomposition and pattern recognition today, so you can check back later, and you can finish them. And I'm thinking of giving some prizes for the best Mad Libs and for the best examples of pattern recognition and decomposition. So hopefully by the end of next week, I can announce the prizes. Are you all good with that?
Yes.
Yeah.
Okay. So yeah, I'll talk to you guys later next week. And if you have any questions, you can hang out. I'm here. I'm not ending the meeting yet.
Okay, bye.
All right. See you guys. Sanvi, are you able to follow it okay?
Yeah.
Any questions? Were you able to get into the class?
Yeah.
Awesome.
Thank you.
Yeah, you're welcome. Sahar, do you have any questions on the class? I see that you did an exercise. I'm going to take a look at what you did.
Actually, I just went on to look at it and I didn't get to do it yet.
Oh yeah, okay. So yeah, there is no submit button. All you have to do is just open it up and start typing. You should be able to do that.
Thank you.
Yeah, give it a shot. Maithili, did you have any more issues? It looks like you were in and out.
No, it was fine.
Okay, good. Any questions? Did you miss anything? You want me to explain anything? Were you able to follow the decomposition and pattern recognition that we talked today?
Yeah.
You all good?